writing. Here we have given open loop transfer function of any control system as k upon s plus 1. So this is our open loop transfer function, for which we have to draw the root locus, where k denotes your variable gain, and range of k will be from 0 to infinite, right? So if this is given to you, is open loop transfer function is given to you, how will you proceed after this step? So first thing is you have to analyze how many number of poles are there. Number of poles here are 1. How many numbers of zeros are here? Number of zeros here are 0. So p minus z will give 1. So if you see step number 6, that is, if the number of open loop poles is greater than number of zeros, the number of root locus branches terminating at infinity is given by p minus z. So that means in our case p minus z is coming out to be 1. So one branch, can say that one branch will terminate at infinity. Right? We will see how that branch is terminating at infinity. Now location of poles and zeros is also we can see. So location of poles can be seen is given by s is equal to -1. Pole is present at location of -1, and we generally denote pole by cross line. And there are no zeros, so there is no point of calculating 0. So I will draw an S-plane here. Let us suppose this is your S-plane. This is your origin. This is your real axis. Again and again, I will not write that this is a real axis and this is an imaginary axis. I will simply write S-plane. So you have to assume that which is x-axis is your real axis and y-axis is your imaginary axis. Okay. So if we see here in this open transfer function, the pole is present at s is equal to -1. So let us suppose this is my point. Let us suppose this is my point, and -1 point is here. So there is a pole at s is equal to -1. So this is step number 1. This is step number 1 we have covered. Step number 1 and 6 we have covered. Step number 1, what does it say? Locate open loop poles and zeros. Step number 2 is what is step number 2? Step number 2 says any point on the real axis is a part of root locus if the total number of open loop poles and zeros to the right hand side of that point is odd. If I consider this as my point, and if I see the right side of this pole, you will see that total number of poles and zeros which are present on my real axis is 0. So that means 0 denotes your even number. So this, from this point to plus infinity, will not be my part of your root locus. Now suppose if you are at minus infinity, and you are seeing from minus infinity, if you analyze, the total number of poles and zeros from minus infinity is 1, right, to the right side, so which is odd. So this will be my part of my root locus. So step number 2 is done. Step number 3, what does step number 3 says? Step number 3 says root locus is symmetrical about real axis and it originates from open loop poles and terminates at open loop zeros. The root locus starts from open loop, that is at open loop pole at the value of k is equal to 0. This is my open loop pole and the value of k is 0 here, and it originates from open loop poles and terminates at open loop zeros. Since there are no zeros, we will see how our root locus branch is terminating. Root locus is symmetric 8. The root locus branches terminating at infinite will do so along a straight line called asymptotes. Now we will discuss about something about asymptotes. So if number of poles are greater than number of zeros, which is in our case, number of poles here are 1, number of zeros here are 0. So there will be one branch which will be terminating at infinite. Now you have to calculate or show how this one branch is terminating at infinite. The root locus branches which is starting from here can terminate either like this, can go like this, can go like this, can go like any way. You have to see by how it is terminating at infinite, right? So we will see. So it will terminate at infinite along the asymptote. Along the asymptote. What is asymptote? We will see. So for that you need to calculate angle of asymptotes first. Angle of asymptote is given by alpha, which is by calculated by 180 degree 2q plus 1 upon p minus z. Right? I'm continuing here. Where q will be ranging from 0, 1, 2 to p minus z minus 1. In this case, p minus z minus 1 will be equal to 0 because p minus z is already 1. So p minus z minus 1 will be equal to 0. So value of q will be 0. So if you put value of q here as 0, so alpha will come out to be 180 degree. Right? So alpha we have got as 180 degree. Now since you are having an alpha, you want to draw that angle. So for drawing that angle, you need some point, right? For drawing that angle, you need some point. That point is called as centroid. Or this. So what is the formula for centroid? It is summation of real part of poles minus summation of real part of zeros upon p minus z. So this is the formula for centroid. Summation of real parts of poles. If you see what the poles here, poles are present at minus 1. Poles are present at minus 1. So my summation of real part of 1, that is minus 1 minus there are no zeros, so 0 will be there. And p minus z is 1. So minus 1 by 1, so you will get 1. So this is the point, this is your centroid, right? From here you have to draw 180 degree angle. So this is 90 degree and this is 180 degree. This angle is 180 degree. So from one point I have drawn 180 degree angle, and this will be my asymptote, straight line. So my branch which is terminating at infinite will do so along a straight line along the asymptotes. This is my asymptotes. So this k is equal to infinite. Here k is equal to 0. I will again draw. I will again draw the diagram root locus. We are having one pole at k is equal s is equal to minus 1. At s is equal to minus 1, value of k is 0. And we have got is flowing from k is equal to 0 to k is equal to infinite to minus infinity. So your 1 0 will be lying at infinity. So this will be the complete root locus for our first question, right? So this is our open loop transfer function which has been given. For this transfer function, we have to draw the root locus. Again, the procedure is same. You need to determine number of poles here are 1, number of zeros here are 1. So p minus z will give you 0. Pole location of pole is minus 1. Location of zeros is at minus 2, right? So let me draw. So this is my S plane. This is my origin. So look, if pole is present at minus 1 and 0 is present at minus 2. So this part, I hope it is clear. Now, if you are standing at point 1, minus 1, see to the right side of this minus 1, the total number of poles and zeros present and the real axis is 0, right? So this will not be your part of your root locus. Now we will shift our focus to -2. The total number of poles and zeros present to the right hand side is 1. So this will be my part of my root locus. Now after moving from here to, if you again see from pole, so this will not be my part of my root locus. If you are again standing at minus infinite and see total number of poles and zeros on the real axis, which is 2. So this will not be, again, this will not be my part of my root locus. So my root locus branches will only exist between -1 and -2. And root locus branches will start from k is equal to infinite at open loop pole and terminate at k is equal to infinite at open loop 0. And direction of this will be from pole to 0. So this is my root locus diagram for second question. Open loop transfer function has been given to you of any control system. Consider this as your open loop transfer function. K s plus 1. Kindly mute your audio. S into s plus 2. So again, total number of poles here are 2. Total number of zeros here are 2. Location of poles is at 0 and -2. You can see location of zeros is at -1 and -3. I hope this much is clear. Again and again, the same step I have been following. Now I will draw the S plane. Now quickly draw the location of poles and zeros. Poles are present at s is equal to 0. At s is equal to 0, one pole is there. At s is equal to -1, 1 0 is there. Pole is there at s equal to -2, 0 is there at -3. So this is my origin. This is -1 point, -2 point, and this is -3 point. This is my s. So we have drawn s. We have drawn the location of poles and zeros. Now, if I'm standing at this point, see toward the right hand side on the real axis. Total number of poles and zeros are even, which is 0, which is even. So this will not be my part of my root locus. Now you are standing at this point. See the total number of poles and zeros to the right hand side of this pole. The total number of poles and zeros are 1. So this will be my part of my root locus. Now you are standing at this point. Total number of poles and zeros here are even, which is 2. So this will not be my part of my root locus. Now you are at this point. Total number of poles and zeros to the right hand side on the real axis is 3, which is, so therefore this will be my part of my root locus. If you are again back to this point, again observe that total number of poles and zeros on the real axis is 2, which is even. So this will not be my part of my real root locus. If you are standing at -infinity, observe to the right hand side of -infinity, total number of poles and zeros present are 4, which is even. So this will not be my part of my root locus. So root locus branches will only be present from here to here and here to here. And we know that root locus branches start from k is equal to 0 and terminate at k is equal to infinite. Root locus branches start from k is equal to 0 from open loop pole and terminate at k is equal to infinite. So this will be my complete root locus for question number 3. So question number 4 is open. We have given open loop transfer function as a upon s into
Sir?
s plus. Yeah.
So in question number 3, you gave the direction to the opposite side that you drew in the notes.
In notes, I can see the root locus branches will flow from k is equal to 0 to k is equal to infinite. It will start from open loop pole and terminate at open loop 0.
Yes, sir.
Okay. Now we will see question number 4. Total number of poles here are 2. Total number of zeros here are 0. P minus z will give me 2. Right? Location of poles, if I see, is 0 and -1. There are no zeros, so we do not have to worry about 0. So first step is to locate poles and zeros. This is my first step, so I will do that. Mute your audio. So pole is present at origin. One pole is present at origin and another pole is present at -1. So this is my -1 point, this is 0. If I am standing here and if I am moving to the right side of this pole, total number of poles and zeros on the real axis is 0. So this will not be my part of my root locus. Now I'm standing here and observing to the right hand side of this pole. Total number of poles and zeros are 1, which is odd. So this hole will be my part of my root locus. If I'm standing at -infinite and observing to the right hand side of -infinite, total number of poles and zeros are 2, which is even and which will always remain an even. So my root locus branches will start from here to here. It starts from k is equal to 0. This is k is equal to 0 at open pole. Now we see one root locus branch is coming from this side. One root locus branch is coming from this side, another root locus branch is coming to this point, and they are both approaching a common point. So now we will see the concept of a breakaway point, right? How to calculate breakaway point? We will just see how to calculate breakaway point. So breakaway point you can calculate by 1 plus g into h by making 1 plus gh is equal to 0. So 1 plus k upon s into s plus 1 is equal to 0. So this will give me k is equal to minus of s square plus s. dk by ds, we have to do dk by ds is equal to 0. That means minus of 2s plus 1 will be equal to 0. So 2s plus 1 will be 0. So s will be equal to minus of 1 by, which is minus of 0.5. So this is my point, minus 0.5 will be my breakaway point. So at this point, these two branches will collide with each other and one branch will move in any direction. Let us suppose in any direction it can move either this way, this way, this way, or this way. That we have to see which way it will move. But right now what we can say is they are interacting at common point, which is minus 0.5. So once they have interacted with each other, now you have to calculate. Now you have to see step number 5. See step number 5. What does step number 5 say? The angle at which root locus branches leave or approach the breakaway point is given by plus minus 180 by r. So that is given by plus minus 180 degree by mod of r, where r is the number of root locus branches leaving or approaching the breakaway or breaking point. So total number of branches which is leaving or approaching here are, this is one branch, this is second branch. So two branches are approaching this breakaway point, so r will be 2. We are having plus minus 90 degree. So after colliding, one branch will move like this, another branch will move like this, and we do not know how it will terminate. Calculate how these branches will terminate at infinite. This branch can go like this, can go like this, can go like anywhere, can go like this also. Okay, so now you want to calculate how this branch will terminate, because it has started from k is equal to 0, so it has to terminate at k is equal to infinite. Now you want to know where this branch will terminate, which we will do right by calculating asymptotes, right? The branches which are terminating at infinite will do so along asymptotes.
So we'll have to take out the centroid actually.
Yeah, so first we have to calculate first asymptotes. Let us see how to calculate asymptotes. So asymptote is calculated by alpha, angle alpha, which is given by 180 degree, 2q plus 1 upon p minus z, where q is ranging here from p minus z, here is 2. So p minus z minus 1 will be, p minus z minus 1 will give you 1. So values of q will be 0 and 1. Put value of q 0 and 1 by 1 to this formula. right? If you put q is equal to 1, 0, we will get plus 90 degree and plus 270 degree. If you put q is equal to 1 here, 0 and 1, if you put 1 by 1, you will get these two values. So this let us suppose this branch is the root locus branch. This is minus 0.5. This is angle plus 90 degree, and this is angle plus 270 degree. So after intersecting, one branch will move upward, another branch will move downward, right? Sorry, I forgot to calculate centroid. So you will calculate centroid also. Centroid is real summation of real part of poles. Summation of real parts of poles. So poles here are at 0 and minus 1. So it will be minus 1 plus, minus 1 minus, there are no zeros. So minus 1 minus 0 upon p minus z is given by 2. This will come out to be minus of 0.5 only. So this is our centroid. From here, the two branches are giving, and this is my asymptote. And along the asymptote, my branch, root locus branches is terminating at infinite. Giving, and this is my asymptote. And along the asymptote, my branch, root locus branches is terminating at infinite. One branch is going like this k is equal to infinite. Another branch is going like this k is equal to infinite. So this is the completion of question number 4. We will fastly see question number 5. We'll quickly see question number 5 before this lecture ends.
So we need not to show 270 degree.
I have shown plus 270 degree. See on the page on the notes.
Okay, sir.
Question number 5. Open transfer function GS into HS is given as K S plus 1 S into S plus 2 to S plus 3. This is my open transfer function. So I will just skip all the steps. I will draw the finally root locus. This is my S plane, let us suppose. Location of poles here are at 0. 0 is at minus 1. There is 1 0 at minus 1, minus 2, and minus 3. This is minus 3, minus 2, minus 1. This is 0. So this will be my part of my root locus. So k is equal to 0 is here, k is equal to infinite is here. This will start from here and it will terminate at infinite. This is k is equal to 0. K is equal to 0 at open loop pole. Value of k is 0. If you are at this point, see this will be my part of my root locus. So there must have been a breakaway point. So in order to calculate breakaway point, what you need to do is GS plus HS is equal to 0. So when you do that, when you do GS plus HS is equal to 0 and find out the roots, so you will get 3 roots, which is as follows. One root is at minus 2.46, and other 2 roots will be minus 0.7 plus minus j 0.8. These will be the 3 roots which you will be getting after putting 1 plus gs and doing dk by ds is equal to 0. This will be 3 roots. So if you analyze this root, this root is lying here, right? Which is not my part of my root locus. This is not my part of my root locus, so we will omit this roots and we will consider this as a breakaway point, because this is the point which will lie between minus 2 and minus 3. So suppose this is minus 2.46, because this point is not lying on my root locus. So we will omit this and we will consider minus 2.46. Now we will see plus minus 180 by mod r formula. So this will again come out to be plus minus 90 degree. One root locus branch will be like this, there will be like this. Now we need to calculate how these two branches are terminating at infinite. That we will do by calculating asymptote. We calculate angle of asymptote. We will get again 90 degree and 270 degree we will get as angle of asymptote. And now we want to calculate centroid. So centroid will be minus 2 minus 3 summation of real part of zeros, poles minus summation of real part of pole 0 or minus 1, and p minus z. The total number of poles here are 3, total number of zeros are 1, so p minus z will be 2. If you calculate this, so it will come out to be minus 2. So this is my centroid. Right now this is my centroid, and this is my asymptote look like. This is my asymptote will look like. So branch which is coming from here will gradually shift to this point and will terminate at infinite. Branch which is break-up point from here and will move across to the infinite. So this is k is equal to infinite. So this is the solution for question number 5. The point transfer function has been given to you as k s plus 1 upon s into s plus 2 into s plus 3. So this is our open loop transfer function where k is a gain. We will vary gain from 0 to infinity such that when k is equal to 0, the location is pole. K is equal to infinity, the location are zeros. So this is what we have to do. So first step is to see how many numbers of poles are there. Number of poles are 3. Number of zeros, if you can identify, are 1. So p minus z will give you 3 minus 1, that is equal to 2. That means 2 branches of root locus will terminate at infinity. One branch will terminate at 1 0, which is present here, and 2 branches will terminate at infinity, and that 2 branches which will terminate at infinity will do so along asymptote that we have also seen in the previous classes. Now we will see what are the location of the poles. Location of poles. So one pole is at 0, one pole is at minus 2, and one pole is at minus 3. These are the 3 locations of 3 poles. Then location of zeros also we have to find out. Location of zeros are simply at minus 1, right? So these are the location of poles and zeros. Now I will draw quickly pole 0 plot. This is your S-plane which I am drawing. Pole is present at origin. 0 is present at minus 1. Another pole is present at minus 2, and this is another pole minus 3. So this is minus 3 pole, minus 2, this is minus 1, and this is 0. So these are the locations of poles and zeros. Now we have to see whether your real axis, that is this axis. Now we have to see whether your real axis, that is this axis, is part of your root locus or not. So how to check that? For checking that, we need to first be on this point, see to the right side of this point, of this pole, how many numbers of poles and zeros are there on the real axis. This is my real axis. How many numbers of poles and zeros are there? There are no poles and zeros, which is 7. So this will not be my part of my root locus. We will move forward to this point. Now see how many numbers of poles and zeros are here to the right side of this point. There are 1 pole. That means it will be my part of my root locus, which is, there is 1 pole which is odd. So this is my part of my root locus. Now be at this point. Now see, check on the right hand side of this point. Total number of poles and zeros on the real axis are 2, which is even again. So this will not be my part of my root locus. We'll move to this side. Check to the right side of this pole. Check to the right side of this pole. Total number of poles and zeros are 3 on the real axis, which is again odd. This will be my part of my root locus. So this whole will be my part of my root locus. So at pole, value of k is 0. At pole, value of k is 0. At 0, value of k is infinity. At pole, value of k is 0. So this is how it is done. So one pole is starting from here. Another root locus branch is starting from here. This root locus branch is starting from here and it will terminate at k is equal to infinite. So this is a complete root locus, one root locus branch. Number of root locus branch. How many number of root locus branch we are having? Number of root locus branches. Number of root locus branches will be given by order of the system. Order of the system. Or number of open loop poles. How many number of open loop poles are there? 3. So one branch is starting right here and terminating at this point. So this is one branch. Another branch which is starting from here is and another third branch is starting from here. These two branches will collide with each other. So there will be a breakaway point. So we need to find out what is breakaway point. Breakaway point. How to find out breakaway point is we have seen that is 1 plus gs into hs, make it equal to 0. If you do 1 plus gs, hs is equal to 0. So k will be equal to minus of s into s plus 2, s plus 3 upon s plus 1. Now what you need to do is you need to do dk by ds, differentiate this k with respect to s and equate it to 0. If you differentiate this and equate it to 0, you will have S1 is equal to minus of 2.46, S2 is equal to S2 and S3 will be complex conjugate, that is minus 0.7 plus minus J 0.8. This will be the points. So if you see minus 2.46 can lie between these minus 2 and minus 3, whereas minus 7 plus minus J8 is somewhere here, which is already not our part of our root locus. So we will consider this as our breakaway point, and this will be our breakaway point. At this point will be our breakaway point, that is minus 2.46 will be our breakaway point. So now we need to see at which angle my root locus branches will leave the breakaway point. It can leave like this, it can leave like this, it can leave like this, it can leave like this. So we need to find out at which angle my root locus branches. We need to see at which angle my root locus branches will leave the breakaway point. How to do that? We use formula that is plus minus 180 degree by mod of r. Then r is the number of root locus branches approaching to the breakaway point. The number of root locus branches which is approaching to this breakaway point is 2. So plus minus 180 by 2. So we will get plus minus 90 degree. Plus 90 degree is this, and minus 90 degree is this. So after breaking away, it will depart at plus 90 degree and minus 90 degree. Right? So now we need to find out how these branches will terminate at infinite. We have found out at which angle it is leaving the real axis, but we want to find at how it will terminate at infinite. This branch can go like this, and any way it can go. We need to find out how it will terminate at infinite. So how we will find out that? We will find out that by using asymptotes. We will calculate asymptotes or angle of asymptote, that is alpha, that is equal to 180 degree to q plus 1 upon p minus z. This is the formula for calculating asymptotes. And what is q here? Q will be ranging from 0, 1, 2 to p minus z minus 1. So p minus z is given as p minus z is 2 here, and p minus z minus 1 will be 1. So values of q will be 0 and 1 only. So one by one put values of q here. So alpha you will get at as 90 degree and 270 degree. These are the two values of alpha that you will get. So I will just erase some of part of it. Yes. So values of alpha that we are getting is 90 degree and 270 degree. This is alpha, angle of asymptote. Now you need some point where you can draw these angles. So that point is called as centroid. We have seen this in previous class also, given by sigma. What is how to calculate centroid? That is summation of real part of poles minus summation of real parts of zeros upon p minus z. This is a formula. So if you see, the real parts of poles are at -2, -3, and zeros is present at -1, minus of -1 upon p minus z, that is 2. That will be equal to -5 plus 1 upon 2. So my centroid will be at -2. So -2 is this point. I will once again draw the root locus. So pole is present at origin, then 0 is present, then again pole is present, and again pole is present. So this is 0, this is -1, this is -2, this is -3. One branch is starting from here and terminating at here. One branch is starting from here, another from here, and they are intersecting at breakaway point. This point is -2.46. After intersecting, one branch is living like this, another is living like this. Now you need to draw centroid. For centroid is -2. This is -2 point here, and you need to draw angle of 90 degree and 270 degrees from centroid. Plus 270 degrees. That angle you need to draw. So I will just draw the angle. So this is my asymptote. So one branch which is living like this will ultimately follow the asymptote and will terminate at infinite. One branch which is living like this will ultimately follow my asymptote and will terminate at infinite. So this is k is equal to infinite here and k is equal to infinite here. So this is how my total root locus will look like. This is k is equal to 0, k is equal to 0. At open loop pole, the value of k is 0, and this is infinite. So this is my complete root locus of my given open loop transfer function. Now we will move forward to the next question. This is our open loop transfer function which has been given. We have to draw the root locus such that the value of k should range from 0 to infinity. You have to vary the value of k from 0 to infinity. So total number of root locus branches will be order of the system or total number of open loop poles, which is 3. Poles, location of poles, if you want to see. Now poles are 0, -1, -2. There are no zeros, so we do not have to worry about 0. I will just draw the location of poles and zeros on my S-plane. So pole is present at origin. Pole is present at origin, -1. Let us suppose this is -1. Let us suppose this is -2. This is -2, -1, and this is origin. Right. So this is our location of poles. So if you are again, you have to analyze whether the real axis is part of your root locus or not. If you are standing here, this will not, right side of this is always 7, so this will not be part of my root locus. If you are here at -1, see to the right side, total number of poles and zeros on the real axis is 1, so this will be my part of my root locus. If you are here to the right side, total number of poles and zeros are even, so this will not be my root locus, part of my root locus. If you are at -infinity, and if you are seeing to the right side, the total number of poles and zeros are 3, which is always odd, so this will be my part of my root locus. So at open loop pole, value of k is equal to 0, k is equal to 0 here, k is equal to 0 here. So it will originate from open loop pole root locus branches will originate from open loop pole. Now you see these two branches are intersecting at some point, so you need to find out this breakaway point. Breakaway. So straight away we will jump into calculating breakaway point. How will you calculate breakaway point? By 1 plus gs into hs is equal to 0. So k will be equal to minus of s into s plus 1 into s plus 2. This is your k. Differentiate it with respect to s and equate it to 0. So values of s1 you will get as minus, the value of s1 will you will get minus 0.42. Value of s2 you will get, so you will get two locations minus 1.57. Now if you analyze minus 1.57 will lie somewhere here, which is already not our part of our root locus. So we will omit this and we will consider minus 0.42 because minus 42 will somewhat lie here. This will be our breakaway point, minus 42. Now you need to, so you have calculated breakaway point. Now you need to calculate at which angle your root locus branches will leave the real axis, that you will calculate it plus minus 180 by r, mod r. The mod r is the number of root locus branches leaving or approaching the breakaway or breaking point. So plus minus 180 by, in our case it is 2. So we are having plus minus 90 degree. So one branch will leave at 90 degree, another branch will leave at 90 degree like this. Now you need to find out asymptotes because you do not know how this branch will terminate at infinite. It can go like this, it can go like this, like this. So you need to calculate angle of asymptote for that. So for calculating angle of asymptote, you need to write its form. Know its formula, it is 180 degree, 2q plus 1 on p minus z. Q will be ranging from 0, 1, 2 to p minus z minus 1. P minus z minus 1 in our question is p is 3 minus 1, 0 is 2. Q will be having three values 0, 1, and 2. Corresponding to the each value of k, q, the values of it will be 60 degree, 180 degree, 300 degree. Calculate it. It will come out to be this only. Now once you have got this alpha, you need to calculate what? Centroid. Centroid is what? Summation of real parts of poles minus summation of real parts of zeros upon p minus z. Real parts of poles are 0, minus 1, minus 2, minus of, there are no zeros, so 0. Again, p minus z is 3 here. So minus 3 upon 3, that will get as minus 1. So we are having centroid at minus 1. Right? So we need to make angles at minus 1. So I will just make the angles. This is minus 1 point. Make 60 degree angle like this. 180 degree is like this. And 300 degree will. Sorry. 180 degree angle will be like this. And 360 degree will be like this. This is your asymptotes. You have got asymptotes, you have got centroid, and you have also got your breakup and breaking point. Just try to rub this part. Now we finally draw the root locus, the branch which is coming from here. And one branch is coming from here. They will intersect with each other. One branch will move like this. Sorry for this. After intersecting, one branch is coming from here. Another branch is coming from here. After intersecting, one branch is moving like this. Another branch is moving like this to infinite. The branch which is coming from here will follow asymptote and will go to infinite. So this is the case of infinite here, equal to infinite here, is equal to infinite here. Right? So this is the complete root locus we have drawn, but still there are some parts which we can calculate. So we will see what are those parts. Now if you want to calculate this part where your root locus is crossing your j omega or imaginary axis. How to calculate that? Yeah, I've told you that you calculate that by using Routh-Hurwitz criteria. So this is your characteristic equation. If you see, you have to build a Routh-Hurwitz criteria for this. You keep your notes by your side. I will just erase the whole page and I will let you know how it is done. So why we are doing that? Because we want to know at which point this is cutting the real imaginary axis. At this point, we need to know what is the value of j omega and what is the value of k here. So we will do that. Routh-Hurwitz criteria. What is our characteristic equation? If you want to get what is our characteristic equation, plus s cube plus 3s square plus 2s plus k. So s cube will be higher order. This is 2, this is 1, and this is 0. See the notes by your side, which I have provided. This is the table which we have filled. We have seen. Now, in order to make this row, in order to make this element to 0, we have to make this O of z, because we know by Routh's criteria, when all the elements of any row is 0, then that system will be marginally stable system, such that all the elements in the first column should have same sign, right? So we want to make this element to 0. 6 minus k by 3 should be equal to 0, so k should be equal to 6. So at k is equal to 6, your root locus branches will cut your j omega axis. Now you want to know the value of omega also, to put the value of k here. So this will be your auxiliary equation. Auxiliary equation will be 3s square plus k equal to 0. So 3s square, the value of k is 6. So 0. So s will be equal to plus minus, or s will be equal to plus minus j root 2. Right? So I will just draw the complete root locus again. We are having one pole here, another pole here, another pole here. Minus 1. So this is your angle of asymptote. Let us suppose this is your angle of asymptote, and this is your third angle of asymptote. So one branch which is originating from here, another which is originating from here, they will intersect with they will go like this. Leave the relation go like this. The value of j is here is plus j root 2. Value of this is minus j root 2. And value of k here is 6. Value of k is 6. Value of k is 6 here. Another branch, the root locus branch is coming here and going to infinity here. Value of k here is 0, value of k here is 0, value of k here is 0. So from this, what we can say, this root locus is that if k, when value of k is between 0 to 6, the system is stable system. We have seen this in the class. If value of k is equal to 6, the system is marginally stable system. And when value of k greater than 6, that means the root locus branch is crossing the and going over to the right hand side, then system will be your unstable system. This completes your second root locus. Open loop transformation is given as k upon 4 into s into s plus 4 into s square plus 4s plus 20. This is the transformation, open loop transformation, which has been provided to you. So you have to draw the root locus for this question. Now, startingly, you can say number of poles. This is a big question, so you keep your note by your side because I need to erase it. So number of poles, if you see, total number of poles are 4. Number of zeros, there are no zeros. Location of pole. Location of pole, if you see, one pole is at origin, one pole is at -4, and if you find out the root of this equation, s square plus 4s plus 20, then you will get poles as -2 plus minus j4. These are the 4 locations of my poles. So total number of branches of root locus is given as P. Total number of poles, which is 4. We have 4 branches. Number of branches terminating at infinity is given by P minus Z, which is 4. So 4 branches are there. 4 branches will start from, all the 4 branches will start from open loop pole where K is equal to 0, and all the 4 branches will terminate at infinite. So if you want to see the location of pole, I will just draw it very roughly. This is our S plane. One pole is at here, one pole is at here. Another pole is here, another pole is here. So this is -4, this is 0, this is 4, and this is -2. So these are the 4 locations of my pole. So we need to draw the root locus for this question. Kindly switch off the audio from your side. If you see, one branch will start from here. If you are here and see to the right side, if there are no poles and zeros, that means 0, that means even. So this will not be part of my root locus. If you are standing at this point, see towards the right side of this point, total number of poles and zeros on the real axis. This is my real axis. On the real axis is 1. So this whole will be my part of my root locus from here to here. So this whole will be my part of my root locus from here to here. This will be a part of my root locus. If you are standing at -infinity and if you are observing to the right hand side, total number of poles and zeros are 2. One pole is at here, another pole is here on the real axis. So the total number of poles and zeros, if you are standing at -infinity, is 2, which is even. So this will not be part of my root locus. So my root locus, so my real axis which will be part of my root locus, will be from here to here only. And it is starting from here and going here. So we will be having a breakaway point somewhere here. So what we need to do is we need to find a breakaway point. So we will quickly find out its breakaway point. Breakaway point. How to find out breakaway point is we have already seen 1 plus GS into HS to make it equal to 0. Right? 1 plus GS HS is what? K upon S into S plus 4 to S square plus 4S plus 20 to make it equal to 0. Then you take the LCM. So K will be equal to minus of S plus 4 S square plus 4S plus 20. Now what you need to do is you need to differentiate this and equate it to 0. So currently the order is 3. If you differentiate it, order will be 3. So there will be 3 roots, S1, S2 and S3. You will find 3 things or 3 roots, you can say. What are those? You can see directly. So one is at -2 and another 2 are -2 plus 2.4 J minus 2 minus 2.4 J. So these are the points. Now if you see, -2 is where? -2 is lying here, which can be our breakaway point, and this -2 plus 2.4 J is somewhere here. So we will see whether this is our part of our root locus or not, or whether this is our breakaway point or not, right? So currently we will take -2 as our breakaway point. So our breakaway point will be -2. Now we need to calculate at which angle the root locus branches will leave the real axis. We will calculate this one plus minus 180 by mod of r. So this plus minus 90 degrees. R is 2 because 2 number of branches are approaching this. R will be equal to 2. So we are getting plus minus 90. So we have calculated what we have calculated breakaway point, and we have calculated at which angle the root locus branches will leave this. Right. So next, what we will find out is we will find out if this is coming here. Then we will find out there will be 4 branches which will be terminating at infinite. Right. So we need to find out asymptotes. Angle of asymptote, which is 180 degrees. 1 upon minus z. If you do p minus z minus 1 will be 4 minus 1 3. Q will be we will be having this much value. 1 by 1 you put Q here, so alpha you will get as 45 degree, 135 degree, 255 degree, and 415 sorry 315 degree. So this will be the alpha. And centroid, you need to get centroid, from where you will draw alpha. How to calculate centroid? Summation of real parts of poles minus summation of real part of zeros upon p minus z. Poles are present at origin minus 4 real part. Now see here real part. This is pole. This is my location of 2 poles. The real part of pole is only minus 2. This is my imaginary part. So I will consider minus 2 times because there are 2 poles. This is how we will calculate summation of real part of pole minus real part of zeros. Zeros are not there, so we will simply put 0. P minus z is 4. So minus 4 minus 2 minus 2 actually give me minus 8. Minus 8 divided by 4. We will be having minus of 2. Centroid we are having minus 2. This is the point where minus 2. I will just rough erase all the things, and again I will freshly draw the root locus. Here we have calculated centroid. We have calculated angle of asymptotes. We have also calculated the breakaway point. We have got 3 points, from which 3 points we have took this point s is equal to minus 2. So we have calculated up to this much point. Now again, one pole is at origin, another pole is at minus 4. Suppose this is minus 2. This is J4. So minus J4. So another pole is lying at plus J4. So these are the locations of 4 poles. And we have what we have find out is this whole will be our part of our root locus, right? And this will be our breakaway point, and it will leave at plus 90 degree and minus 90 degrees. So this much we have seen. And we need to draw an angle of asymptote also. Centroid is minus 2 only. Quickly we will draw asymptotes of angle minus 45 degree. Let us suppose this is very rough diagram. Let us suppose this is 45. This is how you will draw asymptotes. This is 45 degree. This is 135 degree. And similarly, all the degrees, this is asymptotes and centroid we have calculated. Now, when this is intersecting here and it is breaking away, now we need to find out how this the root locus branch will begin from this pole. It can begin like this, it can go 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 in any direction. So we need to find out angle at which the root locus branches will depart from this pole. So that angle we will say this as angle of departure. Angle of departure. Right? So what is the formula for angle of departure? We have seen that is 180 degree minus phi p minus phi z. This is how we will calculate angle of departure. And we have what is phi p? Angle contributed by other poles. Angle contributed by other poles. And what is phi z? Angle contributed by other zeros. This is phi p and phi z. Now if I erase some of this part, and if I erase this also, let us suppose I will erase. This was my so let us first calculate phi d1 for this pole. Let us calculate phi d1 for this pole, right? So what does phi p means? So phi p means angle contributed by all the other poles. Means this is one pole. What is the angle contributed? So we will always see the angle in this way. Angle will be calculated only for positively only in this way only. If you want to calculate negatively, then this will be quadrant. Then this will be the rule we will follow. Otherwise, we will follow the angle will be, we will calculate angle only from in this way, in positive quadrant way. So angle contributed by this pole, by other poles means this is what are the other poles? This is another pole, this is another pole, this is another pole. Let us suppose the angle contributed by this pole is phi p1. Let us suppose the angle contributed by this pole is phi p2. Let us suppose angle contributed by this is phi p2. Sorry, phi p3. This is angle contributed by this pole. This is phi p2. This is phi p1. And this is this is phi p3. So we need to calculate all phi p1, phi p2, and phi p3, and we need to sum that. So that will be phi p, and phi z is 0. Why? Because there are no zeros. So we will be having only phi p. So we will one by one we will calculate what is phi p. Now if you observe, this is -2 here, -2 point is here, and this is 4 here. So length of this will be 4. So from here to here it will be 2. From here to here this is 2, and this is what, 8. So this is simple quadratic geometry. If you want to calculate phi p1, let us suppose we are first we will calculate phi p1. Phi p1 is what? Somewhat this is given. So this is your phi p1 is coming out. So this is 2 and this is 4. So for calculating phi p1, let us first calculate this angle. That's theta. Theta will be what? Theta is what? This opposite, and this is base. Opposite by base, that is 4 by 2. We can calculate tan inverse of opposite by base. Tan inverse of 4 by 2, or theta will be equal to tan inverse of 2. So if you calculate what is tan inverse of 2, let me check what is tan inverse of 2. Tan inverse of 2 is 63 point. So theta will be equal to 63.4 degree. Theta is this. So what will be phi p1? Phi p1 is what? This is phi p1. So 180 degree minus 63.4 degree. So this is phi p1. Now calculate phi p2. Phi p2 for phi p2, the triangle is like this. Phi p2. This is 2. This is 4. So again, it will be tan inverse of 4 by 2. Phi p2 is nothing but 63.4 degree. Now, if you calculate phi p3, calculate phi p3. This angle. See this angle. This angle is what? 90 degree only. This angle is 90 degree. So what is phi p? Phi p is phi p1 plus phi p2 phi p3. Calculate all those to add phi p1 with phi p2 with phi p3. So minus 63 plus 63 will cancel out. We will be having 180 plus 90. That will be 270 degree. So phi d1 will be what? 180 degree minus 270 degree. That will be equal to minus of 90 degree. So phi d1 is minus 90, what we have got. And by symmetry, we we have seen the rule that the root locus is symmetrical about real axis. This is your real axis. So if phi d1 is like this, starting like this, so phi d2 will be upward direction, that is plus 90. To make it symmetrical, it will be plus 90 degree. I will just erase it and I will just again write it. So phi d1 we got as minus of 90 degree. Now, if you want to calculate phi d2 also by analytical way, like we have calculated phi d1, we can do that. So I will just show you. Otherwise, what you can use is you can use symmetrical property, that root locus is symmetrical about real axis. If phi d1 is minus 90, then phi d2 will be plus 90. Otherwise, just follow what I am doing. This is one pole, this is another pole, this is another pole, this is another pole. So phi d2 will be calculated for this. Phi d2 will be this. What is phi d2? Angle contributed by this pole to this. What is angle contributed by this pole? This is the whole angle. So you need to calculate this angle. So this is, let us suppose this is phi p1. What is angle contributed by this? This will be the angle contributed by this. Phi p, let us suppose this is phi p3. Angle contributed by this. This is the angle contributed, that is phi p2. So this is the angle contributed by the pole under consideration for phi d2. That is, we are calculating angle of departure for second pole. Now, if you want to calculate phi p1, what is phi p1? This is nothing but 180 degree, and this is what 2, and this is 4. If you draw like this is 2, this is 4, and you need to calculate this angle. So this will be tan inverse of, again, this is opposite by base. So an inverse of opposite by base. Opposite by base, which is equal to 63.4 degree. So, sorry, this is not phi p1. Let us suppose this is theta. This is theta. So phi p1 will be what? Theta plus 180 degree. This will be 180 degree plus 63 degree. 63.4 degree. This will be my phi p1. Now calculate phi p2 quickly. Phi p2 is this angle. Phi p2 is this angle. This is what? 270 degree. Just something like this. So for phi p2 I'm drawing. This is 2 and this is 4, and this is my, let us suppose theta 1. So calculate theta 1. Theta 1 will be what? Tan inverse of opposite. Now this become 2 and base is 4. Tan inverse of 2 by 4. So that will be equal to, I think 90 minus 63. 6. 9 minus 3 will be 6. 26.6 degrees. So this will be 26.6 degree theta 1. Now phi p2 will be, you can do 180 degree plus 26.6 degree. So this is phi p2. And what is phi p3? Phi p3 is what? Phi p3 is angle contributed by this pole to here. This will be my phi p3. So this is 90 degree, this is 180 degree, and this is 270 degree. So 270 degree will be my phi p2, phi p3. So finally phi p will be equal to 270 degree plus 180 degree plus 63 degree plus 180 degree plus 26.6 degree. So finally phi p2 will come out to be, phi p will come out to be 810 degree. So phi p is 810 degree. So phi d2 will be, phi d2 will be phi 180 degree, sorry, 180 degree minus phi p minus phi z. 180 degree minus of 110 degree. So this will be equal to what? Minus of 630 degree. So phi d2 we got, yeah.
So can you please explain 5p3 once more?
Yes, yes. 5p3 is what? P3 is angle contributed by this pole to this pole. This we will calculate 5p3, and we will calculate angle by this way. This whole angle will be 5p3. If you want to take this, so this will be negative. But if you want to be a positive and not make mistakes in exam, so this will be the angle. So this will be my 5p3. 5p3 is from here to here. You can see it is 90 degree. From here to here, it is 180 degree, and here, so 90, basically 90 plus 90 plus 90. It will be 270 degree. Okay. So 5d2 is what we are getting. 5d2 is minus of 630 degree. Minus of 630 degree, or what else you can write? Minus of 360 degree, minus of 270 degree. You can do like this. So if this is my pole, so for 5d1 we get 5d1 we have got minus 90 degree, and 5d2 we have got minus of 630 degree. So minus 90 for this will be like this. So the root locus branches will go towards downward direction. By symmetry, you can directly draw like this, because if this is going down and root locus is symmetrical about real axis, then you can directly draw. You need not need to calculate all of this stuff, but you still need to be assured for your understanding purpose. That's why I have shown it to you. Now, how will you draw? Next question is, how will you draw minus of 630 degree? Minus 6. How will you draw minus 630 degree? So suppose this is, yes.
So excuse me. So can you explain 5p2 again? Like how did you find 5p2?
5p2 is what we have calculated. This angle contributed by here to this total angle. If you 5p2, this is the angle contributed, and if you want to calculate again,
So 5p2 will be 270 degrees plus 26.6.
yes, 270 degree. Why 270 degree? Let me check. This is the angle contributed by 5p2. So this is 90 degree. This is 180 degree. This is 270 degree. Yes, 270 plus. Yes, 270 plus. So yes. So what I have done? I have written wrong.
So it can be 360 minus.
Yes. You can do that. You can do that also. If you want to calculate the whole angle, this is 360 degree and minus this angle.
This angle is 63.4.
Yes, this angle is 63.4. Yes. You can do that. Okay. So the purpose is to show you there is no need to calculate 5d2, because it will always be symmetrical, right? It will, if this is going downwards, and if it's symmetrical, root locus is symmetrical, so this will go upward to make it symmetrical property. But still, for your
sir, if we calculate for one side, the next will be the mirror image of the first.
Exactly. That's what. That is what I am telling you. It is symmetrical about the real axis. This is my real axis.
Yes, sir.
This is my real axis, and if it is and this is my pole, if this is root locus branch is going downward, then mirror image it will go upward, or symmetrical. You can call it symmetrical or mirror image, right? There is no need to calculate for 5d. Yes.
Sir, do we have to show the calculation for 5d2?
That is what I'm telling you. This is for your understanding purpose. There is no need to calculate 5d2. It can be it can be the mirror image of 5d1. If this is going, this 5d1 we have already calculated, which is minus 90. So angle of departure for this pole will be, let us suppose this is our pole. Angle of departure is minus 90 degrees. So this is minus 90, right? So root locus branches will go downward. So this branch has to go upward to make it symmetrical or mirror image property, which is a property of root locus. This is our real axis. It has to be symmetrical about real axis, right? If it is going downward, so it has to go upward. Let us say that we want to calculate phi d2. We do not want to rely on the property. That is what I have done. I've tried to show you. So minus 360 minus, we have got finally minus of 630 degree. Minus of 630 degree. How will you calculate? This is minus of 360 degree. I've taken one, and again I need to do minus of 270 again. So this is what I have done doing. So this is totally what? This is 600 minus 630 degree. Again, we can see that this is coming upward, right? So this has to go up in upward direction. So one is going downward, another is going upward, right? So this is how we will calculate phi d1 and phi d2. I will just erase all the things. Again, draw it. So what we have seen so far is one pole here, one pole here, one pole is at 2, like this. This hole is my part of my root locus. This is minus 2 point here. This is going upward, this is going downward. This branch is coming from here, this branch is coming from here. Now, if you see, both of this branch will intersect at some point. So you need to calculate this point also, this breakaway point, which what we have calculated. Again, if you see on the notes, we have calculated 3 breakaway points. If you turn the pages and try to see, we have calculated 3 breakaway points. S1 was minus 2, and S2 and S3 was minus 2 plus minus J 2.45 or 46. This was our second point. So this is what our, this is 2, already 2, and this is J 2.46. This has to be J 2.46 because this is already 2. This point is 2. Phi d1 is minus 90. It will go like this. By symmetry, it will go like this, and at some point it will again meet. And after meeting, they will again deviate from one another by angle plus minus 180 by 2 degree. This is up till here we have covered. We have also got phi. Phi we have got as 45, 135, 225, and 315 degree. Also, we have got centroid as minus 2. So keeping centroid as minus 2, this is minus 2, draw 45 minus 45, like this. So after breaking away at this point, one branch will go like this, another branch will go like this with the centroid to the infinity, another branch will go like this to infinity, this will go like this. K is infinite, K is equal to infinite here, K is equal to infinite here, and K is equal to infinite this point. So this is how our root locus will look like. Now, this is not complete. If you want to calculate this point, what is this point? We'll calculate this point and what is the value of K, the value of K at this point, and what is its location. So we will do this by also its. And for outside roots, we require characteristic equation. Characteristic equation for this case is characteristic equation we are getting is s to the power 4 plus 8s cube plus 36s square plus 80s k is equal to 0. This is the characteristic equation. Make the routes table. This is s to the power 4 and highest power is s to the power 4. So this will be 1, 36, and this will be k. Here it will be 8 and 80. Right. Fill the next row. This will be 26 equals k. This will be k. Fill the next row. This will be 2080 minus 8k upon 26, and this will be 0. Next will be, this will be k. So to make marginally stable, this has to be 0. This element has to be 0. So 2080 minus 8k upon 26 has minus 26 has to be 0. So From here, value of k you will get as 260 degree. Sorry, 260. So this value is 260. Here where it crosses j omega is 260 degree. So sorry, not 260 degree. It is only 260. Value of k here. Value of k is 260 here. Now you need to calculate what is those points. You will calculate those points by this equation, auxiliary equation. 26 s square plus 260 will be 0. S square will be equal to minus of 10. S will be equal to plus minus j root 10. So this point and this point. Here the value is plus, sorry, minus j root 10. Here it is plus j root 10. I will again draw the root locus. We have calculated all the points. So I will just rub it and draw it again. Draw the whole root locus again. Well, my pole, one of my pole is here. One of my pole is at origin, another pole is at minus 4. Suppose this is minus 2 point, and another pole is here, another pole is here. This is the point J4 plus J4. This whole will be my part of my root locus. From here, this part, but pole value of k is equal to 0. Pole value of k is equal to 0. Value of k is equal to 0. So we have, what we have got is we have got the centroid also. Centroid is minus 2. So we will draw angle of asymptote also. Right, quickly we will draw asymptote. Let us suppose this is our asymptote. First, let us suppose this is our asymptote. So one branch will go downwards, another branch will go upward. We have seen from phi day 1 and phi day 2. And after this breakaway point, one branch is going upward, another branch is going downward. So at certain point, they will intersect with each other. Let us suppose this point is this. Corresponding to the value of here, j here is j 2.4. And here, I have not drawn it correctly, so I will just erase. Another point is this. Let us suppose this is minus j 2.4. So after breaking away, this is breakaway point for this two branch. This is breakaway point for this two branch. After breaking away, this will move here, and this will move here. So go like this, and go like this, and this will go like this. So now you need to calculate this point. This point k is equal to 260 k is equal to 260 degree. Sorry, 260, and s is this is minus j root 10. Value of this is plus j root 10. This is k equal to 0. This is k is equal to infinite. K is equal to infinite here. K is equal to infinite here. Equal to infinite here. This is imaginary axis. This is this plane. So this is the complete root locus for your question. It is having 4 branches. If you want to see what are the 4 branches, again I will write the question for you. GS is given as k upon s into s plus 4 s square plus 4s plus 20. This was your question. If you see, poles here are 4. So 4 branches will be there, 4 branches of root locus, which are this, 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 and this. All are terminating at infinite. So this is the complete root locus for your question. Next things we will cover, if we have seen, is breakaway or break-in point. Calculation. Right? So here what we do is we take the characteristic equation. How we will get the characteristic equation? By doing 1 plus GSHS is equal to 0, by making this, and by making k at one side and all the other terms on the another side, and then differentiate it with respect to s and equate it to 0, and then you will have some values of s. That is, suppose different values of s. Then you have to select particular value of s or breakaway or break-in point which suits or which fits best in your case. So this is the first formula. Second formula we have seen is how the root locus branch will leave the real axis. That is quite simple. That is 180 plus minus 180 by mod r. What is mod r here? R is the, here r is equal to total number of branches leaving or approaching breakaway or breaking point. So this is the second formula. Third formula what we have seen is if p minus z is greater than 0, that means poles is greater than 0, then p minus z number of branches will terminate at infinity. Suppose p is equal to 4 in some question and z is equal to 2. In this case, p minus z will give you 2. So 2 branches is terminating at infinity. Right? So 2 branches will terminate at infinity. And we are having 2 branches more. So total there are 4 branches because number of poles is equal to 4. So there will be 4 branches. Out of those 4 branches, 2 branches will be terminating at infinite, and remaining 2 branches will start from open loop pole at k is equal to 0 and will terminate at open loop zeros at k is equal to infinite. The value of k or gain at open loop pole will be 0, and the value of gain at open loop 0 will be infinite. So 2 branches will start from open loop pole and terminate at open loop zeros, and remaining 2 branches will terminate at infinity. So those 2 branches which are terminating at infinity will do so along with the asymptotes that we have also seen. That asymptote we can calculate by alpha or angle of asymptote, that is equal to 180 into 2q plus 1 divided by p minus z. Here q will be ranging from 0, 1, 2 to p minus z minus 1. This is the formula for calculating alpha. Now if you are drawing an angle that is asymptote, then you certainly need some point, a point of reference from which you can draw these angles. So that point is called a centroid or center of gravity that we have already seen. The formula for calculating centroid is summation of real parts of poles minus summation of real parts of zeros divided by p minus z. So this is a formula for calculating centroid. Next, we have also seen angle of departure and angle of arrivals. So this angle of departure, that is phi d, and phi a, angle of arrival. Why we need to calculate that? So angle of departure and angle of arrival. Suppose if we are having any complex conjugate poles, then how the root locus branches will start from this point? It can go like this, like this, like this, like this. So this is decided by what? Angle of departure. Angle of departure is given by 180 minus phi p minus phi z. So this is the formula for calculating angle of departure, where phi p is the angle contributed by all the other open loop poles, and phi z is the angle contributed by all the other open loop zeros. So this is about angle of departure. And what is angle of arrival? Angle of arrival, why you need that? You need that if you are having complex conjugate open loop zeros like this. So at zeros, you already know that k is equal to infinity. At zeros, the value of k is infinity, and your root locus branches will terminate at open loop zeros. So how will the branches will arrive to this? Whether they will arrive like this, whether they will arrive like this, like this, like this, at which angle they will arrive. So that is given by angle of arrival. So this is nothing but the reverse of this. So this is 180 minus phi z minus phi p. This is how you calculate the angle of arrival. So please be very clear what is angle of arrival and what is angle of departure. Apart from that, you are having two more formulas. First one is magnitude criteria, where you put mod of GH is equal to 1. This is used to calculate the value of gain k at any point on the root locus. By using this formula, you can calculate the value of k by putting the subsequent values of s. Next formula is angle criteria, where you have put angle is equal to 180 degree to q plus 1. Q, or you can write instead of q here, since we have already used q, you can write small k if you want. The small k will be ranging from 0, 1, 2 to infinity. So these are the sets of formulas which we will require to draw any root locus apart from the rules which we have already seen. So without wasting further time, we will see some numericals. Okay. So last time we were seeing one numerical. Our meeting got over without completing that numerical, so we will see that again. So we will see that example again. Question was like this: G s into h of s is given as k upon s into s plus 4 s square plus 4s plus 20. This was the question. The location of poles we have seen as 0, minus 4, minus 2 plus minus j4, and there are no zeros. So straight away, if I want to draw the root locus, there is one pole at origin, one pole at minus 4, and two poles are like this. Right? This was the original how you will locate open loop poles and zeros. So this is suppose minus 2 point. This is j4 and this is minus j4. So what we have left over at that point was calculating angle of departure. Let us suppose the angle of departure for this point is phi d1 and for this pole is phi d2. You need to calculate only phi d1, and phi d2 will be the opposite of phi d1. Right, because of the rule that root locus is symmetrical about the real axis. So if phi d1 is if something if the branch is living like this, then phi d2 the branch will live like this, because it is symmetrical about the real axis. So we need not need to calculate for phi d2. If we will calculate for phi d1, that is enough. So let us see how we will calculate phi d1. What is phi d1? Angle phi d1 will be 180 degree minus phi p minus phi z. So this is the formula. So phi p is what? Phi p is angle contributed by all the other open loop poles. This is the angle contributed by all the other open loop poles. This is what the angle contributed by this pole. Let us suppose this is phi p1. Angle contributed by this pole, let us suppose this is phi p2. Angle contributed by this, let us suppose this is phi p3. Phi p will be equal to phi p1 plus phi p2 plus phi p3. Now if you want to calculate phi p1, phi p1 will be what? First you can what you can do is you can calculate this angle, that is theta. Let us draw the triangle there. This is theta. The height is 4 and the base is 2. So theta will be equal to tan inverse of 4 by 2. So tan inverse of 4 by 2, when you will do that, what you will get is 63 degree, 63.4 degree. This is theta. So what will be the phi p2? Sorry, phi p1. Phi p1 is something like this. This is suppose theta, and this is phi p1. So phi p1 plus theta, you can say it is 180 degree, or phi p1 will be equal to 180 degree minus theta, right? 180 degree minus 63.4. Let us suppose phi p1 is coming this. Now we will calculate phi p2. Phi p2 is what? Again, draw the triangle. This is the triangle. This is 4. This is 2. Then this will be 63.4 degrees as you have seen. So phi p2 will be 63.4 degree. Now angle contributed by phi p3 will be angle contributed by this phi p3. This is, you can see, this is 90 degree directly. So phi p will be equal to 180 minus 63.4 plus 63.4 plus 90. Minus 63 plus 63 will cancel out, so this will be minus 270. Sorry, plus 270 degrees. So my phi d1 will come out to be 180 degree. Since there are no zeros, so phi z will be 0. Minus 270. This will be the, so phi d1 will be equal to minus of 90. So my angle of departure for this pole is minus 90. Minus 90 means if this is my reference, this will be my minus 90. So root locus branches will leave like this. If phi d1 is minus 90, therefore phi d2 will be equal to plus 90. By mirror image, if this is my reference, so this is my plus 90. So this is angle of departure for both of my cases, phi d1 and phi d2. So up to this we have seen. So we have calculated phi d1 and phi d2. I will just erase the drawings, and I will just quickly draw the final root locus graph. One pole is at origin, another pole is at minus 4. Let us suppose this is minus 2. This is, so this will be, my part of root locus we have seen, because the total number of poles to the right side of this pole is odd. This is starting from here, this is starting from here. This is k is equal to 0 here, k is equal to 0 here. The branch is going downwards, this is going upwards. breakaway point we have calculated. We have got breakaway point -2 plus minus j 145. This we have already done. So this is my breakaway point. After breakaway, it will leave, one branch will leave like this, another branch will leave like this, and they will intersect. This is -2 points, so this will be perpendicular. This will go down. They will intersect at some point. So that point is -2 plus j 2.4. This is minus j 2.4. After intersecting, we have also drawn on its centroid and asymptotes. This is what I'm drawing is asymptotes and centroid. What we have got is -2. You can check by your notes. You have done this calculation in the previous class. So after it breaks away at this point, one branch will move like this, but another branch will move like this. This is k is equal to infinite. This is k is equal to infinite. After breaking away from this point, one branch will move like this, another branch will move like this. Since k is equal to infinity, k is equal to infinity. Now, if you want to calculate this, then you can calculate by Raoult-Hurwitz. We have seen this, and after drawing the Raoult's table, applying it on characteristic equation, find the value of k, and put the value of k in auxiliary equation, then find the value of s. After doing all that, what we have got, the value here is, the value of this point is j under root of 10, and value of gain at this point is 260. Similarly, this point, value of this will be minus j root 10. Value of k at this point is 260. This is the complete root locus. So if my open loop transfer function is given like this, k s square minus 2s plus 2 upon s square plus 2s plus 2. This is my open transfer function. The number of poles here are 2, number of zeros here are 2. So p minus z will be equal to 0. So no branch will terminate at infinity. All the branches will start from open loop pole at k is equal to 0 and will terminate at open loop zeros at k is equal to infinity. Now you need to know what is the location of poles. If you find out the location of pole, it will come out to be -1 plus minus j. And location of zeros, it will come out to be +1 plus minus j. How you calculate the location of pole? Simply by calculating the roots of this numerator and denominator, right? So in this question, what we will do is we will calculate angle of arrival and angle of departure. So it will be more clearer to you. Let's suppose this is -1 point, this is +1 point, this is +1, this is S plane. This is your S plane. This is j omega axis, this is real axis. This is suppose plus j point, this is minus j point. So this is the location of poles here, and this is the location of zeros here. Okay. Now what we need to do is we need to calculate, since we are having no poles, open loop poles and zeros on the real axis, so there is no need to calculate the total number of poles and zeros to the right hand side of that rule. We will directly have to calculate angle of departure, that is phi d1 for this one and phi d2 for this, sorry, phi a1, angle of departure and angle of arrival. So first we will calculate phi d1. What is phi d1? Phi d1 will, so phi d1 will be equal to, use the formula 180 degree phi p minus phi z. Now you will calculate phi p. Phi p is what? This is pole angle contributed by this. So this is phi p1. Phi p is equal to phi p1, that is equal to plus 90 degree. You can see this if you move from here to here, so this will be plus 90 degree. Now we have to calculate phi a1, sorry, phi z. Phi z will be the angle contributed by these two open loop zeros. Let us suppose the angle contributed by this is this, and angle contributed by this will be something like this. This is the angle contributed by this open loop zeros. So let us suppose this is phi z1, sorry, phi z2, and this is phi z1. So phi z will be equal to phi z1 plus phi z2. How we have to calculate phi z1? Phi z1 you can see directly, that is 180 degree. It is 180 degree. And what is phi z2? Phi z2 is what you can draw a right angle triangle. This is supposed to be your phi z2. Calculate this theta. This is what? This is 2. This height is 2. And base is also 2. This is the base and this is the height. So both are 2. So it will phi z2 you have to calculate. So that will be equal to 180 degree minus of theta. Theta is tan inverse of 2 by 2. It will be 45 degree. So phi z2 will come out to be 180 minus 45 equal to 135 degree. So phi z2 you have calculated, phi z1 you have calculated. So phi z will be equal to 180 plus 135. So 180 plus 135 will give me 315 degree. Right? Now you have to calculate phi d1. Phi d1 was what? 180 degree. Phi p minus phi z. So 180 degree minus phi p is what we have calculated as 90 degree. So 90 minus phi z is 315 degree. 315 degree. So 180 degree minus, so 90 minus 300 will be minus of 225 degree. So minus will be plus. That will be equal to 180 plus 225 degree. So that will be equal to 405 degree. Or what else you can write? 360 plus 45. If you are taking a whole circle, you can neglect 360 because it is a round part. So your angle of departure will be 45 degree for phi d1. If angle of phi d1 is 45, therefore phi d2 will be equal to minus of 45. You can directly write it like that. So we have calculated two angles. I will drop it. So this was the original question. We have got phi d1 as 45 degrees. So this is 45. So root local branches will something leave like that, and it is minus 45 for lower pole. So it will leave like that. The root local branches is leaving like that. If you want to calculate for this question angle of asymptotes, alpha will be equal to 180 2q plus 1 p minus z. So sorry, you do not need to calculate alpha because alpha you will calculate only when the root locus branches is terminating at infinity, and since there are no branches which will terminate at infinity, so we not need to calculate angle of asymptote or centroid. Now you have to calculate what? You have to calculate the angle of arrival, that is phi a1 and phi a2. You have to calculate two things. So we will do that. Phi a1 is the angle contributed like this. So angle contributed by this will be, let us suppose phi p1. Angle contributed by this will be phi p2. And angle contributed by this will be, let us suppose phi z1. So phi A1 will be equal to, now formula will be reversed for calculating angle of arrival, so it is phi z minus phi p. You have to calculate phi z. Phi z is simple. Phi z is equal to phi z1, simple as 90 degree, and phi p will be equal to phi p1 plus phi p2. Phi p1, you can see the angle contributing by this pole is 0, and phi p2 is this angle. You can draw the triangle if you want. This is phi p2. The height is 2 and base is also 2. So it will again come out to be 45 degree. Okay, so phi A1 is what you will get, 180 degree minus 90 minus 45. So you will get 180 degree minus 45. So that will be equal to 135 degree. So if phi A1 is equal to 135 degree, so phi A2 will be equal to minus of 135 degree by mirror image property. So what we can do is we can draw the root locus, final root locus. One pole, another pole. This is 0, this is 0. Angle for this is phi z for 45. Angle for this is minus 45. Angle for this is 135. So this is 90 degree. This is 180 degree, and this is 135 degree. It will leave like this. For this, it will be minus 135 degree. It will leave like this. It will start from here and terminate here. Start from here and will terminate at this point. The directions will be like this. K is equal to 0. K is equal to infinity. K is equal to 0. K is equal to infinity. Now, if you want to calculate this point, you can do that by using Raoult-Hurwitz. You can calculate the value of K here, and you can also calculate the value of point of S that you do by yourself.